Hi everyone, Mrs. Greenman here. I'm going to work through some of the review problems with you here. The first problem we're going to look at is number 2. When graphing a rational function, remember the first thing you want to do is you want to simplify. So you want to factor your numerator and you want to factor your denominator so that you can find your points of discontinuity. So if we factor the numerator, we still have x minus 3, and if we factor the denominator, it's a difference of two perfect squares, so we have x minus 2 and x plus 2. So remember, our domain, we want to think about all values that are excluded from our domain. So since we have a denominator here with an x minus 2 and an x plus 2, we know that x cannot equal 2 or negative 2 because it would cause the denominator to be 0. So we have discontinuities at the values of negative 2 and 2. Now, if you look, we do not have a factor that cancels in the numerator and the denominator, so there's no hole here in our graph. These discontinuities are going to be vertical asymptotes. So we're going to have a vertical asymptote at x equals 2 and x equals negative 2. So in this case, we do not have any holes. So when you're sketching your vertical asymptotes, remember on your graph that your vertical asymptote should be dashed. Okay, so this is x equals 2. And then this is x equals negative 2, and it's helpful if you draw them dashed as well as labeling them. So this is x equals 2 and x equals negative 2. Remember that there are 3 cases with your horizontal asymptotes, and the way to determine what the equation of the horizontal asymptote is, we look at the degree of the numerator and the denominator. So in the numerator, the degree is 1, and the degree of the denominator is 2. When the degree of the numerator is smaller than the degree of the denominator, your equation of your horizontal asymptote is y equals 0. So we can also draw in our horizontal line at y equals 0, our horizontal asymptote, drawing that dashed as well, and labeling. That's just on the x-axis. So if we have a horizontal asymptote, there's going to be no slant asymptote. And lastly, the 2 key features we want to find of our rational function are the x-intercept and the y-intercept. So when we're looking for our x-intercept, that's the value when y, or f of x, is 0. So we're going to take our simplified expression here, and we have 0. We're going to replace y with 0 equals x minus 3 over x minus 2 times x plus 2. Now, if we were to solve this for x, the first thing we would do is we can multiply both sides by the denominator, and we would have just 0 times x minus 2, x plus 2, so that's going to cancel. So we get 0 equals x minus 3, and if we solve this, we get x equals 3. So our x-intercept is 3, 0. So we can also plot that here. So this would be 3 here maybe, so 3, 0. We also want to find our y-intercept. When we want to find our y-intercept, remember that's when we replace every x with a 0 and we're looking for y. So if we replace every x with a 0, we have 0 minus 3 over 0 minus 2 times 0 plus 2, and we end up getting negative 3 over negative 4, which is 3/4. So our y-intercept is 0, 3/4. So we can graph that there. 3/4 is 0.75. So if we go and we have our scale of our y-axis, let me just draw my scale in here. So 3/4, maybe that point would be over here. Okay, so now how do we put this all together? So we're not going to graph this in our calculator. What we're going to do is, we know that our graph usually will ride along your vertical and your horizontal asymptotes, although in this case it's going to cross that horizontal asymptote at our x-intercept. So to figure out sort of what your graph is going to look like, you want to choose some points in each sort of section of the graph, if you will. So we want to pick some x values that are smaller than negative 2, some x values that are between negative 2 and 2, and then some x values that are larger than 2. And we're going to input them into our function over here. I put a table of values for you there, and you can look more closely at the key to see what I did. And you're going to input them, and you're going to kind of see what the graph will look like. So if you do this carefully, your graph will typically, for this graph, is going to look something like this. It's going to ride along the asymptotes, those vertical asymptotes. And in this particular case, your graph actually does cross the y equals 0, the horizontal asymptote. It's going to go up, and then it dips back approaching that line y equals 0. Okay, and then on this side of the graph, you can plot those points more carefully, and this is what it's going to look like. If you look at the key, you will see the table. I have values of x that are to the left of -2, between -2 and 2, and larger than 2. That gives you an accurate picture, so you can make your sketch of your graph more accurate. Okay, I'm also going to work through number 5 with you. And again, the key is posted and it's pretty detailed with every question. So we're going to look at number 5. So for number 5, the first thing you want to do is you want to simplify your numerator and denominator. So when you factor your numerator, you get x minus 4 times x minus 2, and you have x plus 2 in the denominator. So in this case, we don't have factors that cancel, so again, there's no whole here. If this had been an x plus 2 in the numerator with the x plus 2 in the denominator, it would cancel, and that would indicate that we have a whole. So here we have discontinuities at the values of x equals -2, because we can't have -2 in our denominator. Because nothing cancels, we know that that's our vertical asymptote. So our vertical asymptote is at the line x equals -2. So we want to remember to write your vertical asymptote as an equation. So on our graph, we're going to draw that in dashed x equals -2, and we're going to label that. Okay, so here we don't have any holes, as I mentioned, and in this case here, the degree of the numerator is larger, 1 degree larger than the degree of the denominator, which tells us that there's going to be a slant asymptote. Now, to find the equation of the slant asymptote, you're going to use synthetic division. So you're going to take your rational function here, and you're going to set up your synthetic division. So when you set this up, we take the coefficients of your numerator. So we have x squared, -6x, and 8. So that's 1, -6, and 8. And we're dividing that by x plus 2. So we're going to divide it by the root, which is -2. So remember, you bring down the 1. 1 times -2 is -2. -2 plus -6 is -8. -8 times -2 gives us 16. And we're left with a remainder of 24. So our equation, and we're going to disregard the remainder, is y equals x minus 8. So that means we're going to have a slant asymptote at the equation of the line y equals x minus 8. So to graph this, we're going to go to -8, and just be careful of the scale. It's up 1 over 1, but we're going with our scale. So if we go up 4, we're going to go to the right 4, just so you kind of can get an idea. If we go down 4, we have to go to the left 4. Okay, so if we continue this here, we're going to go up 4. We're going to keep plotting this. So generally, this is what your graph is going to kind of look like of your equation of your slant asymptote. Okay, then you also want to make sure that you find your x and your y-intercepts. Again, for your x-intercept, that's when you set y equal to 0. Okay, so if y is equal to 0, we have 0 equals x minus 4, x minus 2 over x plus 2. If we multiply both sides by x plus 2, we're going to end up getting 0 equals x minus 4 times x minus 2. So if we solve this, we know that x equals 4 or x equals 2. So we have two x-intercepts. We have 4, 0, and 2, 0. So if we go ahead and plot those, we have 2, 0, and 4, 0. And then we need to find the y-intercept. That's the value when x is equal to 0. So we want to find y when x is equal to 0. So if we replace every x with a 0, okay, what we end up getting for our y-intercept is 8 over 2, which is 4. So our y-intercept for this graph here is 0, 4. So we're going to plot that as well, right? And now we need to get an idea of what our graph's going to look like. So we have our vertical asymptote at the line x equals -2. So using the table of values, you're going to input some numbers that are smaller than -2 and some numbers that are larger, so we can kind of get a sense of what's happening with our graph. And as you can see, it's going to look like, and it shows you on the answer key, is your graph's going to go sort of looking like this. It's going to ride along the asymptotes here. Okay, go along like this. And on this part of the graph here, we have a point at -8, -20. So I'm going to plot that here, -8, -20. And we also have a point at -4, -24. just to give you guys an idea where this is coming from. Okay, and then your graph kind of goes along this pattern. Again, we're just making a sketch here. And the way we're making our sketches is we're using the key features of the graph. Holes, if there are any vertical asymptotes, horizontal asymptotes, or slant asymptotes, x and y intercepts. And then to get more of an accurate picture, we are choosing values sort of in each section of the graph to the left and right of our asymptotes so we can get a picture of what that's looking like. Lastly, I'm going to work through question number 7 with you. This is a throwback problem. So we're going to look at number 7, a log problem, because this is something that was difficult on the group assessment. So if we take a look at this problem here, there's no way for me to rewrite the left and the right side as the same base. So the way to remedy that is we're going to take the log of both sides. So if we take the log of the left side, and if we take the log of the right side, okay, remember that the exponent here is going to jump over the log using our power rule properties. So we have x minus 3 times the log of 7 equals x plus 2 times the log of 12. And it's helpful to use parentheses here so you remember that you're going to use the distributive property. So log of 7 is being multiplied by the x as well as the negative 3. So here we have x log 7 minus 3 log 7 equals x log 12 plus 2 log 12. Now our goal is to solve for x, so you want to move everything that has an x to one side of your equation and everything that doesn't to the other. So if we rearrange this, we end up getting x log 7 minus x log 12, and that's equal to 2 log 12 plus 3 log 7. Okay, we have an x here and here. So what we can do is we can factor out that x. We have x on the outside, and we have log of 7 minus log of 12. And that equals 2 log 12 plus 3 log 7. I'm just going to move over here. So we're trying to solve for x, so we're going to divide both sides by log of 7 minus log of 12. So x is going to equal 2 log 12 plus 3 log 7 divided by log of 7 minus log of 12. And you can put this all in your calculator. Just make sure to use parentheses for the expression in the numerator and the expression in the denominator, and you will get x equals negative 20.051, rounding to the nearest thousandth. So please check the key. It's very thorough with the review problems.